Okay, some of you are already working ahead, and that's fine, whatever. Okay, so identify the shape of the base for each figure below. What measures would you need to calculate each base area? So again, always sort of think about this as if you had the object in your hand, the irregular shape, meaning like the triangle, the circle, the trapezoid, all of those things would sort of be the base, okay? It would sit on that. Because really what you want to do is calculate the area of the trickiest side and then just multiply it by the height of the object, okay? Now this one doesn't matter because it's a rectangle. Right? Everyone agrees with that? So I would need length and width and height. Oh, sorry. I thought it said to calculate the volume. It just says the area of the base. So I just need length and width. Everyone agree with that? Okay. Next one, triangle. So I would need base, and now this is not a right angle triangle. So this is actually the first time we've seen this. So this is really good. Everyone just look at me for a second, even if you're working on the homework. This is really good because it's not a right angle. So now, all of a sudden, our height is actually cutting through the center of that triangle. And in order to find that height, you'd actually have to use Pythagorean theorem. Okay? Because now our height is not one of the side lengths. It cuts right from the base of the triangle to the highest point. Okay? Next. Circle. And we would need just for, because we're talking about area, right? So we just need the radius. We just need, oh, that looks like an eye. Sorry, the calibration of my smartboard. So we would need, there we go, just the radius, right? To calculate area, and pi, but we all know what pi is. Okay, the next one is a trapezoid. How do I spell it? Trapezoid. And for trapezoid, you need, okay, I'm going to try to label this. You need A, B, C, D, and the height. Okay, so you need the base, the top, the side, and the height. Okay, an easy way that you would have to do the height if it wasn't given is, you know, if you put your height here, that creates a right angle triangle, and you can use Pythagorean theorem again to find it. Okay, generally the height is given just to save you from doing that step, but you could do it if you needed to. Okay? Yeah, the height is basically the thickness of the base, sort of. Is having this door open, like, reflecting on the smartboard weird or anything? Okay. All right? Okay. Identify the shape of the base of this prism. So how many sides are there? 8. So it's a... Oh, I always spell octagon wrong. Someone spell it.
A-C-T-A-G-O-N.
What?
O-C. Oh yeah, O-C-T-A-G-O-N.
Oh, why am I doing... Gone. Yeah?
Yeah, that's six
Yep.
sides, so it's-
Oh, it is a hexagon.
Sorry.
There's 6 sides. There's a reason why the letter X was in my head. I was like, why did I just write an X? Okay. So, the base of the area, the base area of the prism is 30 centimeters squared. And the height is 14 centimeters. Determine the volume of the prism. So really, volume is just your area. Think about it. Like, if you sliced it into all of these tiny little sections, all you're doing is taking area times area plus area plus area plus area, and so on. So all you do is take the area times the height. So volume is area of base times height of the object. So in this case, it's just going to be 30 times 14. Which is what? I know you have
420.
420. Do I have a unit? Centimeters cubed because I'm volume. Volume is three-dimensional, so it always has a cube.
It says squared.
No, because that's a volume. Because it says the volume of the basic.
Right.
But now my solution is an actual volume. Did I just say volume even though I meant to say area?
Yeah.
Okay, now, area of the base is centimeters squared. Area is two-dimensional, it's always squared. Volume is three-dimensional, it's always cubed. I don't want to rush people. Okay. A cylinder has diameter of 9.3 and a height of 5.8. Sketch the thing. Okay. I understand that no one in this room, including myself, is an artist. Okay? I think maybe we'd be in a different class. But you just sketch so that I can recognize it. Okay? Make it actually have curved sides, a circle top, or what have you. Okay? So I can recognize it. So they're saying the diameter is 9.3 and the height is 5.8. Always label with your unit on the diagram. So determine the volume to the nearest cubic centimeter. So volume is pi r squared, which is really the radius or area of a circle, times height. Okay, so I get 3.14. Okay, I need to calculate my radius. I'm using my calculator. So 9.3 divided by 2 gives me 4.65. I'm going to keep all of my decimals at this point, okay? I'll round it at the last point. Because if I drop them, as soon as I square it, I'm losing accuracy. Okay, a lot of you, not a lot of you, some of you are forgetting to square things. So make sure you're squaring this number. So 3.14 times 4.65 to the exponent 2 times 5.8. So I got my volume, and Sean, I know you've done it, so you can check. 393 to the nearest cubic centimeter, so, 94. Centimeter cubed. Okay, what volume of liquid will this cylinder hold to 2 decimal places? Recall that 1 liter is equal to 1,000 centimeters cubed. Okay, so I want to know how many liters, right? So I'm going to set this up. 1 liter is over 1,000 centimeters cubed is equal to, I don't know how many liters, over 394 centimeters cubed. Alright, I'm back to my Zorro method. So I circle my X, draw my Z. X. The first 2 numbers that hit get multiplied. So 1 times 394. Then I divide by the third, which is 1,000. X equals. This will tell me how many liters this cylinder will hold. So it will hold 0.394 liters. Oh, and it says the 2 decimal places. So rounded is 0.39 liters. Okay, this one's nice because it tells me right in the question that 1 liter is 1,000 centimeters cubed. My volume is in centimeters cubed, so I just need to set it up, okay? Remember, I had liters on top, centimeters on the bottom. Make sure you stick to the same unit on the top and the same unit on the bottom. Sound good, everybody? Okay, the volume of